All right, so for the problem number one, let me grab what I worked out. Keep it next to me. All right, so we're going to redraw with one equivalent voltage and one equivalent resistor. We'll start with the resistors because that's pretty easy. Everything is in series inside of this circuit. Actually, I'll do that as a whole node, right? Here's the node. Here's a node. There's a node. There's a node, right? There's exclusively one node in between each of the elements, which means everything in this circuit is in series, which means we can interchangeably move everything around or just add them up. So we add series resistors, 4 plus 3 plus 1 plus 2 gives me 10 ohms. All right, 4, 3, 1, 2. And resistors aren't polarized. They're just, you can swap them, it doesn't make a difference. Whereas if you think of a battery, it has a positive and negative side. That's what we see right here, positive, negative. And so it does matter which way it's facing. So if you needed to draw it all on one side, you could, right? And then here's the 2 volts, 2 volts. Well, is 2 volts facing the same way as the 6 volts? No, they're opposing each other, right? And so it's like this 6 volts is facing the opposite direction as the 2 volt. See how I've drawn the positive side? And then we keep following around. Which way is the 1 volt facing? 1 volt's facing the same as 6 volts. So it looks like that, right? And then here's all the resistors. We've already done the resistors together, but now we have these batteries. So if there's 2 ways that you could draw this. You could draw it with the positive. If you just called 2 positive, that would be fine. But if you called the 2 volts positive, then whenever I added these up, well, this is positive 2 minus 6 minus 1 would be negative 5 volts. That makes sense? So if I drew it this way, it'd be negative 5 volts, 10 ohms. That is an acceptable answer, and it just means that the actual terminals are swapped. The other way to draw it would be there. 10 ohms, positive 5 volts. And if you swap the polarity, then you do lose 2 points there out of 10, and that's because the polarity does mean something. It's not just a made up negative or positive number. Number 2, what is the value of I? Well, I is flowing right here. There's I. But if we kind of follow it around, we see that I is the same flowing throughout the entire circuit. So if I know the voltage drop across the resistor, and we'll call this R1. So going back to what I said about consistent subscripts, if V equals IR, and let's call it the voltage across R1 is the same as the current through R1 is the same at times R1, right? I sub R1 times R1. Does that make sense about the subscripts? So once I know that, well, I R1 is 12 volts divided by 6 ohms is 2 amps. And that's the same as I total, which we called I in this, 2 amps. Right, so what we did was we analyzed just this element right here. And we found its voltage, resistance, and thus current. Next part, what is the equivalent resistance of all 3 resistors? So our equivalent of all 3, in this case, we could also call it R total, because all 3 of them are in series together, and that R total is R series. So the way that I did it was I said V equals IR of all the totals, right? And then I rearranged for R total equals V total over I total. V total was 24 volts. I total was 2 amps. R total comes out to 12 ohms. There are other ways to solve this, and if you got to 12 ohms, you might have done it right. Another way is that you could have said, I went up 24 volts, I dropped 12 volts, and then you multiplied I, that 2 amps by 2 amps, and that would be 4 volts, and you said 24 minus 12 is 12, 12 minus 4 is 8, so I have 8 volts here, right? And that's Kirchhoff's voltage law, what goes up must come down, and then I had the I, and 8 divided by 2 would be 4 ohms, and then you add about 6 plus 2 plus 4 gives me 12. So a few more steps, but it's also correct. This one is just KCL. What goes in must come out of a node. Here's the node right here. So what's going in? I1's going in, I2's going in, I3's going in. What's coming out, right? And the way that it's written on the formula sheet, it says I in equals sum of I out, right? And so what are the I's out? I4 and I5. So as long as you got that right, then you mostly got it right. The rest of that is probably, it could just be math errors. I'm going to put everything in milliamps because that would be the correct thing. So there's 3 humps for, actually we're going to solve for I1. So I'll leave it in the formula. I1 plus 48 milliamps. I3, 17 milliamps is equal to I4, 21 milliamps. And this is 9 times 10 to the negative 3. If you couldn't see that, next time, please just ask me, sir, what is that exponential? It's so tiny. But that says times 10 to the negative 3, which is also milliamps, right? So plus 9 milliamps. And what we see that I1 is essentially 21 plus 9 is 30 minus 48 minus 17. I'm just rearranging the formula now. And I get I1 equals negative 35 milliamps. And so what that's saying is this negative current is that positive current flow is actually coming out of that node. But because we labeled it as going in, it's negative current. So if we had positive current, right, positive I1 or negative I1, it means the same thing. R3, number 4, solving for R3. This one, there's multiple ways to do it. For me, the way that I solved it is I found the R total first because I had I total right here. I had V total, so V equals IR. I'm doing it with all the totals. R total is equal to V over I, which is 10 volts over 4 amps, 2.5 ohms. And then I said, well, these are all in parallel together. So therefore the equation for that R total equals 1 over 10 plus 1 over 20 plus 1 over R3, right? That's all to the negative 1. Another way to write that, instead of saying all of that is to the negative 1, is I just take the inverse. 1 over R total equals 1 over all of those, right? There's the reciprocals. And I know R total, right? We just solved for it, so it's 2.5. And so now, if you're just doing the math, 1 minus 1 over 2.5 minus 1 over 10 minus 1 over 20 equals 1 over R3. All that together, 1 over R3 comes out to 1 over 4, which rearranged, R3 is equal to 4. All right, I'm going to stop.